Hello, my name is Andrew Gaspar, and I'm going to be talking to you about tularemia, better known as rabbit fever. Before we dive too deep into the disease itself, we need to talk about its infectious agent, Francisella tularensis, which is incredibly virulent and requires a very minute amount of organisms to actually infect and cause disease within a host. Its characteristics: it is a gram-negative coccobacillus, an obligate aerobe, it is non-sporing, non-motile, not all of its strains are pathogenic, and it is very morphologically similar to a few other pathogenic bacteria, but most notably Haemophilus influenza. F. tularensis replicates intracellularly in cells of the innate response, usually macrophages, sometimes in neutrophils. It enters through complement proteins or mannose receptors and immobilizes phagosome and lysosome function with its bacterial ACPA, which is a phosphatase. It prevents the formation of what is known as a phagolysosome, which is what would otherwise kill off the bacterial cells. Once the inhibition of phagolysosomes has been completed, the bacterial cells are free to proliferate and eventually lyse a cell before they go find other cells to replicate in and lyse as well. They also avoid CD4 plus T cell mediated killing by inhibiting antigen presentation. There's only about 200 US cases per year, so not the most common of diseases, and only about 2 to 4 US deaths per year with modern antibiotics and medical practices. Its worldwide incidence and prevalence is actually unknown, and as you can see down here in the bottom left, it is not really prevalent at all in the southern hemisphere with the exception of Australia. Its history: it was discovered in 1911. Its infectious agent was first isolated and given to experimental host by George McCoy, who first called it Bacterium tularensis. In 1919, Edward Francis determined that deer fly fever was triggered by the same infectious agent and coined the name tularemia, which is the name it still holds today. It also has a vast history of experimentation within the past century as a bioweapon, but we'll get more into that later. With rabbit fever not being the most prevalent in any area or population, pandemics and epidemics are pretty rare. There's also no person-to-person transmission as far as we know, which limits the opportunities of pandemics and epidemics. Most often, the source of any breakout is a very rural area with large rodent or insect populations. So when you think of your stereotypical farmland with nothing but fields and animals for miles and miles, these are actually the most common sites that disease can be picked up. The largest recent outbreak occurred in Sweden in 2019 with a little under 1,000 infected humans in a single county, and this was a county full of mostly farmland. Rabbit fever is a zoonosis, which means it is a disease that is spread from animals to humans. It is often vector-borne, mostly through ticks, but can also be spread through flies. These insects break skin through bites and allow bacterial entry into the host. We now know that these insects can also accidentally be swallowed through the mouth, which can allow the entry of the vectors carrying pathogens into the body, which can then therefore cause disease. This also usually happens during sleep. Not many people are willfully consuming ticks and flies. We are probably more familiar with is transmission through handling wild animals, especially through hunting and skinning game that is infected. Ingesting water that is contaminated by infected animals is also a pretty common form of transmission. An uncommon but very serious form of transmission is inhaling dust and aerosols, which usually happens during landscape activity. This can cause pneumonia. And again, there is no person-to-person contact transmission. There is currently no readily available vaccine. There was a vaccine available in the 80s and 90s in the Soviet Union, but its credibility was constantly called into question, and it is no longer available. In the US, there has previously been some experimentation done to come up with a vaccine, but nothing has ever been FDA approved. And the only available vaccine for anyone to take right now is available only to laboratory workers who are in constant contact with the infectious agent. Water supplies must also be isolated from possible carriers of the infectious agent, and physical protection, usually gloves, are necessary when handling wild animals that could possibly be infected. Insect repellent is also necessary when in an area full of ticks and flies that could be infected. Hallmarks of what is known as ulceroglandular rabbit fever are skin ulcers at sites of contact with infected animals and insects, which is why it is called ulceroglandular. The hallmark of what is known as oculoglandular rabbit fever are inflamed eyes, which is why it's called oculoglandular rabbit fever. Both of these diseases are types of rabbit fever, also exhibit swollen lymph glands, and another type of rabbit fever that is quite serious is pneumonic, which is when dust or aerosol containing the bacteria are swallowed straight into the lungs, which causes a very bad case of pneumonia. The importance of antibodies in the immune response is very controversial. The effectiveness of the humoral response is not agreed upon. Some people believe that antibodies are important for combating the infectious agent. Others believe that the cell-mediated response is pretty much what does all the work. CD4 and CD8 T cells produce interferons that disrupt pathogenic proteins. And the cell-mediated immunity is more effective at immobilizing F. tularensis because they are intracellular pathogens, and that's what cell-mediated immunity usually deals with. In terms of diagnosis, you can make observations based on signs and symptoms, but you can't be sure without laboratory testing. And laboratory testing usually comes in the form of an antibody test that can take up to 2 days. The most effective combative measure against rabbit fever is antibiotic treatment. And most common oral antibiotics are doxycycline and ciprofloxacin. Antibiotics can also be introduced to the bloodstream via injection to get them there quicker. Antibiotic treatment is highly recommended, with about 30% of untreated cases having debilitating effects or resulting in death. And there are actually some strains where up to 60% of untreated cases have debilitating effects or can end in death. The future. This is probably the most intriguing aspect of rabbit fever. With its infectious agent, F. tularensis, being so incredibly virulent, it has a large potential to be used as a bioweapon. The disease can be spread in aerosol form and induce very bad cases of pneumonia and lymph node diseases among a very wide range of people. In 1970, the World Health Organization actually estimated that 19,000 people would die if rabbit fever was unleashed on a major metropolitan area comprised of 5 million people. So if you were Walter White here and you had to tie up some loose ends, so to speak, and you had the means to acquire rabbit fever, you could unleash it on somebody and probably take care of them. Its history as a biological weapon. It was first experimented with by the U.S. during World War I, but they never felt comfortable enough to unleash it during any biological or chemical warfare. It was almost universally experimented with during World War II by most of the major powers of the world, most notably the U.S., Japan, and Russia. And it was kept by the U.S. as a biological weapon until the 1970s, until they decided that they were going to throw out all of their biological weapons. But the Soviet Union continued production of antibiotic-resistant strains into the 1990s. These antibiotic-resistant strains would have been extremely deadly had they ever been released onto a population of people. No biological weapon containing rabbit fever has ever been used, but the threat is astronomical, and scientists are quite worried that if it ever were released, it would be very difficult to combat. With it being a Category A bioterrorism threat, Attempts to develop rapid rabbit fever tests are ramping up faster than ever. The development of more effective antibiotics and a better understanding of how they affect certain strains is what scientists are trying to achieve. The disease and infectious agent are not currently well enough understood for decisive action to be taken by public officials in the case of biological warfare, so we just want to end up getting to a point where we are able to make informed decisions and protect people in the event of biological warfare. But yeah, so that's just about it. Thank you for watching.